Hello everybody, this is Sindhuja, Assistant Professor in the Department of Computer Science and Engineering, BIHER. Today, this video is about intermediate code generation, which comes under the course called compiler design. Let's begin this section. Intermediate code generation. There are levels in that intermediate code generation. First is source level, then target level. Okay, in source level, it can be identifiers, operators, expressions, statement, conditional iteration, functions. These are the in source level. Abstraction at the target level, memory location, registers, stack, opcodes, addressing modes, system libraries, interface to the operating system. That's it. Then code generation, which means mapping from the source level abstraction to target level abstraction. Then in this intermediate code generation, it is having front-end, intermediate code generator, and machine code generator, which will be the backend, front-end and the backend. Front-end translate the source program into an intermediate representation, and backend generates a target code from intermediate representation. Benefits of this code generation are retargeting is possible. Machine independent code optimization is also possible. Okay, so this is the importance of intermediate code generation. So let's see about syntax directed translation of expression into 3 address code. S tends to ID, which is the expression, which is equal to E. So how we can write the 3 address code for this? It is S code is equal to E code. First we are generating S code as E code. In that E code, what we're going to generate? We're going to replace E dot E to the ID. So place E dot place is assigning to ID dot place. E tends to E1 plus E2. E dot place is equal to new term. E dot code is equal to E1 dot code, E2 dot code, because here we are having 2 expressions, like we want to add 2 variables. So we are creating code for first E1 dot code and E2 dot code. It generate E dot place is equal to E1 dot place plus E2 dot place. It is adding E1 and E2 and it is assigning the value to the E. So this is the basic syntax, or it can be a code for writing the 3 address code. And E tends to E1 star expression E2, which can be written as first E dot first we want to create a label, right? E dot place is equal to new term. Then E dot code is equal to E1 dot code, E2 dot code. Again, it's the same thing which we did in addition operation. Again, we are generating E dot place is equal to E1 dot place into E2 dot place. Next, syntax directed translation of expression. E tends to minus E1. It's a continuation of the previous expression. So some more examples here we are going to discuss. E tends to minus E1. What it will do? It wants to minus E1 and then it wants to assign to the value of E. First, for assigning the value, we want to first create one temporary value like E dot place is equal to new term. Then E dot code is equal to E1 dot code. Already, as I said, we want to create a variable. So E1 dot code and generate E dot place is equal to minus E1 dot place. Then E tends to E1. It's a parenthesis. So E dot place is equal to E1 dot place. E dot code is equal to E1 dot code. Just we are giving that E dot code to E dot code. So next E tends to ID, which means E dot place is equal to ID dot place. First we are assigning that ID to the E dot place. So E dot code is equal to, we are telling it is just a character going to assign to the value E. Next example, for this 3 address code, for A is equal to B star, I mean B into minus C plus B into minus C. So here the process will be in the order, which will be in the priority basis. First, what it is doing? First, it is doing B star minus C. In that B star minus C, which is the priority minus C. So first, we are doing minus C and assigning the value to the temporary value T1. Then we are doing B into T1. Okay, so first priority is done. Next, we are doing T3 is equal to minus C. T4 is equal to T into T3. So, and we are assigning the value to T4. And T5 is equal to T2 plus T4. And A is equal to T5. Flow of control. We're going to discuss about the topic flow of control for this 3 address code. Okay. So S stands to while we do S1. Let's start begin. What we're going to do, E dot code. First, what does while process will do? Till that while is executing, do S1. Till that E dot code is true, do S1. Otherwise, go to end the process. This is what while loop will do. So here E dot go, in E dot, first we are doing E dot code. Okay. When if that E dot place is 0, then go to S after, which will stop the execution. Otherwise, keep on doing S dot code. Keep on executing S dot code. Okay. And again go to, so what it is doing, it is executing X dot code, and it is again going to go to S dot begin. So again it's executing E dot code, and again it's going to, till it is coming to 0, it will execute again and again this while loop. Okay. Next one is flow of control for if E then S1. E dot code, if E dot place is equal to 0, go to S dot else. Otherwise, execute S1 dot code. Go to S dot after. After executing S1 dot code, go to S dot after. What is that S dot else? If it is 0, it will come to S dot else, right? There it will execute S dot code. So here it explains that expression, right? If E, then S1, else S2. So this is how the flow of control for if else function it is executed. So it's the same in the right side. S dot else is the new label. Okay, so S dot after, which is also the new label. We are creating that new label for S dot else and S dot after. Next, we going to write a code for S dot code, which is E dot code. What is that? E function. Okay, then we're going to generate if E dot place is equal to 0, go to S dot else. S1 dot code. Next one, we want to execute S1 dot code, and then what we are doing, generating code to S dot after. After that, what we are doing, generating S dot else. After that, S2 dot code. After that, generate S dot after. So this is how this condition if then else function is working for flow of control statement. Okay, then Boolean expressions. Now we're going to discuss about the Boolean expressions. Computer logical values. It's a change the flow of control. Boolean operators are, it can be and, or, and not. So these are all the Boolean operators. So we can write the expression with the Boolean operators like E, it's E dot code. Okay, E comes to E or E, E and E, not E, parenthesis inside the E, and ID, reload ID, true or false. So these all are the Boolean expression. Next, we're going to discuss about the method of translation. How we're going to translate this Boolean expression. This will evaluate similar to the arithmetic expression. Normally use 1 for true and 0 for false. Implemented by the flow of control, even we are giving the expression E1 or E2. Okay, if E1 evaluates to true, then E1 or E2 evaluates to true without evaluating E2. what it is doing, it evaluating if the what the condition E1 or E2. If any one is true, other will also. The whole function is going to be true. If we are executing E1 and we are finding it is a true, then we don't want to execute E2. That is what this code is telling. So if E1 evaluates to be true, then whole expression is going to be true. It don't want to evaluate the next code E2. If it comes false, then we want to evaluate E2 and check whether it is false or the true. If it is true, then it will be true. If it is false, then it will be false. Otherwise, we don't want to evaluate E1, E2 at all. Okay. So we can directly give the answer. Even if E1 is true, then it will come to true. Then numerical expression. A or B and not C. Okay, this is what numerical expression. T1 is equal to not C, T2 is equal to B and T1, T3 is equal to A or T2. What it is doing here also, like the arithmetic expression we already did, right? There is a priority to do. Here they given the expression A or B and not C. So what is a priority first? We want to first assign it's not a C. Okay, so and put the value to the T1. Then what we want to do, we want to assign B and T1. Okay, so next priority is AND function. Sorry, AND Boolean operator. Okay, so AND in AND B and T1 and it is assigned the value to T2. Next is A or T2. So next priority is OR. So first it will execute the priority basis. First not and then AND and then OR. Okay, so finally it will execute A or T2 and finally give the value to the T3 and it will assign the result will be assigned to the value T3, variable T3. Next, relational expression A less than B is equal to A less than B, then 1 is 0. If A less than B, go to 4. Why? It want to assign the value 1. Okay. Otherwise, it will, if it is not A less than B, it is A is greater than B, then it will assign the value T is equal to 0 and then it is go to 5 and it will stop the execution. This is what this expression is doing. Next, syntax directed translation of Boolean expression. So I'm going to give the syntax directed translation for the Boolean expressions which we already discussed in the previous slide, like or, and, not, parenthesis, reload, true or false. So this is what we're going to do. We're going to see how we can write the syntax directed translation. So first, E tends to E1 or E2. Which means E dot in the place of E dot place, we are giving new term. Emit. So emit means like a generate. We are here writing emit. E dot place is equal to E1 dot place or E2 dot place. For the Boolean expression, we are giving that code emit. Okay. So E tends to E1 and E2. So here E dot place is equal to new term. Again, the same like E or we are writing and also. So first we are assigning the value as a new temporary value, a variable E dot place. Then we are giving the function emit E dot place is equal to E1 dot place and E2 dot place. Then E tends to not E1. So for this, what we are doing, that is no two variables, there's only one single variable, but we want to assign the value to E dot place. So E dot place is equal to new term emit E dot place is equal to not E1 dot place. What here, what it was, it is not E1, the not we want to give inside that. But see here all the Boolean expressions are given inside the single quotation. Okay, this is what the syntax for writing the syntax directed translation for the Boolean expression. These are the syntax for that. For every Boolean expression, this is what the syntax we want to use. Okay. E10, next one, next Boolean operation expression is E tends to parenthesis E1. This is just assigning E1 dot place to E dot place. So there is no need of assigning a variable or creating a temporary variable or nothing is needed. That just directly assign the value E dot place to the E1 dot place to the E dot place. Syntax directed translation of Boolean expression for next one. E tends to true. So here true means 1 and false means 0, right? So here we want to assign the temporary variable E dot place and then we want to give the expression. Syntax emit E dot place is equal to 1 and if it is false then give E dot place is equal to 0. Let's see some example for this Boolean expression. Okay, so here we can here I given one expression A less than B or C less than D and E less than F. And first we are writing a code and giving address. It can be like address. We are giving for denoting every line with one number. Okay, first we are starting with the number 100. First we are writing the code. What if A less than B? Then go to 103. 103 what we are assigning T1 is equal to 1. A less than B want to assign 1. Okay, so we are going to 103 T1 is equal to 1. Otherwise, it will execute T1 is equal to 0 and then it will go to 104. In 104, what we have written, the next expression, if C less than D, then it will go to T2 and assign 1. And then assign 1 and then it will after assigning, it don't want to go again to the 104, right? After assigning T2 is equal to 1, it will directly start executing 108. If C less than D is not actually when it is the function is not true, then it won't go to 107. It will directly come to 105 and it will assign the value 0 to T2 and then it will come to 108. So in 108, it is the next expression E less than F. If it is E less than F, then it is go to 101 and it will execute T3 is equal to 1. If it is not, then it will go to 109 step and it will execute T is equal to T3 is equal to 0 and then it will come to 112. What is that in the 112? Now here we are doing, we already did the operation less than greater than that operations we all did because as per the priority, first we want to execute this greater than less than operator and then we want to execute and or operator. So first we finish this greater than less than operator. Now we're going to execute and or. So T4 is equal to T2 and T3. So we executed that and I already discussed, right? First and then only or. Not and then only or. First we executed that and now we're going to execute the or. So T1 we assign the value of result in the T4, right? So we take from the T4, so T1 or T2, which will be assigned to T5. So this is what the example for Boolean expression. Next is short circuit evaluation of Boolean expression. Here we're going to translate the Boolean expression without generating code for Boolean operators, evaluating the entire expression. Okay. Flow of control statements. We're going to discuss flow of control statements for short circuit evaluation of Boolean expression. So if yes is listed code, right? In the S code, we written if E, then S1. Now, in the same thing we already discussed, but we're going to write a code differently. If E, then S1, else F2. While E, do S1. Okay. First. Here, this is the circuit, okay? In this circuit, first it is going to execute E dot code. What is our expression? If E, then S1. So here, first we are going to execute E dot code. E1, right? E means E dot code. So there will be some code in that E dot code. From the result of E dot code, if it comes true, if you want to check whether it is true or false. If it comes true, then what it is, where it is going to execute the code S1 dot code. If it is false, then it is coming out of the circuit and it is ending the process. So this is what the short circuit evaluation of Boolean expression. How we can write a code for this short circuit evaluation? The same. If we then S1 from the circuit itself, we can write a code. Okay. E dot true means it's a new label. We are creating a new label, right? E dot true means why we are creating a new label, because it wants to execute the next code like S1 dot code. E dot false means that we don't want to create any new label because it is not going to execute anything. It's just going to end the process. Okay. So first E dot true, we want to create a new label. But E dot false, it will come directly to the S dot next and will stop the execution. S1 dot next is equal to S dot next. That's it. That is also we want to assign, right? Because S1 dot next, what it will do? It will, after finishing S1 dot code, it want to end the process. So S1 dot next is equal to S dot next. S dot code is equal to E dot code. Or how we are now we're going to generate first step E dot code. It will execute and then it will generate whether true or false. So first E dot true means then it will come to S1 dot code. Okay. Next, the same one we're going to do for if E then S1 else S2. Okay. If E dot code, first in the circuit we can explain E dot code. E dot code means E dot true or E dot false, it will execute. In E dot true means it will execute S1 dot code and go to S dot next. If E dot false means it will execute X2 dot code and then it comes to S dot next. Okay. So this is what the circuit which is explaining. Next is S tends to if E then S1 else S2. E dot true is equal to new label. E dot false is equal to new label. S1 dot next is equal to S dot next. S2 dot next is equal to, which is also S dot next. E dot code is equal to S dot code is equal to E dot code. First we are going to execute E dot code. Then we are generating E dot true. If it is true, then it will come to S dot code, S1 dot code. Then again, it's generating go to S dot next. Then it is generating E dot false. In E dot false, it want to execute S2 dot code, and it will again it will go to S dot next and will stop the process. So this is the difference between E dot code and this difference between E then S1 and also E then S1. I mean E function, if S function. Okay. In if function, there is no need to assign a value for E dot F because it is not going to execute that false function. It will directly end the process. But in E dot if else function, the false function also having some execution to do. So we want to assign the value for F function also. So this is the little difference between if and if else function for writing the short circuit code. Next is do while. Okay, in do while what it will do, till it is true, it will execute S1 dot code. Till it is getting false, when it is get false, then it will end the function. So this is what the circuit is telling. So let us write the execution program for this. While E do S1, E dot begin is equal to new label. Okay, E S dot begin is equal to new label. E dot true is equal to new label. E dot false is equal to S dot next. S1 dot next is equal to S dot begin. Why we are creating, as I said previously, for true false means it is not having any function to do, right? So we are ending the process like S dot next. No need of any new labels and all. S1 dot next is equal to S dot begin. The next S dot code is equal to generate S dot begin. First we want to S dot begin and then we want to execute E dot code and then we want to generate E dot true. which if it is true, then again we want to execute s1.code and then generate go to start begin again to the beginning, and again it will execute from the beginning to the end. So till it is getting false. If it is false, then it will go to start next. First that we already assigned in the previously in the first beginning is also no need to execute again and again in the down also. Okay. Control for translation for Boolean expression. So or again or and everything. Okay, first E1 or E2. First, I already said it for our operation. If it is true, then whole function is going to be true. So if E1 is not true, it means we can decide that E is a true, and we can assign the value E dot true to E1 dot true. If E1 dot false is equal to if it is false, then we want to create a new label. Okay, then E2 dot true is equal to, if E2 dot true means also it will going to be true. Then E2 dot false means then it is going to be false. Okay, so if E1 dot false only, we want to create a new label. The E dot code is equal to E1 dot code, generate E1 dot false, E2 dot code. Next, E1 and E2. So for here, we want to create a new label for everything. Like E1 dot true is equal to new label. Then E1 dot false is equal to E dot false. E2 dot true is equal to E dot true. E2 dot false is equal to E dot false. E dot code is equal to E1 dot code. Generate E1 dot true and again E2 dot code. Okay. Next, control flow transition of Boolean expression for the remaining operators like not and the parentheses. Then if E not E1 means E1 dot true is equal to E dot false. E1 dot false is equal to E dot true. E dot code is equal to E1 dot code. E turns to parenthesis inside E1. E1 dot true is equal to E dot true. E1 dot false is equal to E dot false, and E dot code is equal to E1 dot code. So this is what the Boolean expression for the control flow translations of Boolean expression. Okay. So in R, if it is true, if both any one is true, it is going to be true. In AND, both have to be true. Otherwise, if any one is false, it is going to be false. Okay. In not means it is going to assign the complement. Okay. Not means if E1 means if E1 true means it is going to be false. If E1 false means it's going to be true. So like oppositely. Vice versa operation is going to do for not in. Okay. Next translation. Here code to evaluate E into T. If T is V1, go to L1. Code for S1, go to next. If T greater than or less than P2, then go to L2. Code for S2 and go to next. L2 in L2 line. And same it will execute for L1, L2 and everything. And finally it will come to Ln minus 2. If T gets less than greater than Vn minus 1, go to Ln minus 1. Code for Sn minus 1, go to next. Code for Sn. Okay, next. So go to evaluate E into T, go to test. Okay. L1 is code for S1, go to next. Code for S2, go to next. And code for Sn, go to next. If T is equal to V1, go to L1. If T is equal to V2, go to L2. If T is equal to Vn minus 1, go to Ln minus 1. Then go to Ln and then next. Thank you. So that is all about intermediate code generation we discussed today.